This week's episodes were brought to you by the generous support of Yukofin. Hey folks, Quilly18 here, and welcome to another episode of our Unity Project MightySpud, where we're trying to make a planet, well, a multiple planet rendering system, in fact, in the end. And we're really good and close with the terrain. I'm going to call it good enough for now. We still have to stitch things together, and we probably have to make a slight tweak to our calculation for when we try to determine which pixel to read in, deal with projection mapping and stuff like that. But we've been working on that kind of stuff too long, and it's been sort of a lot of like hard kind of crunchy work that's hitting the bounds of my ability to math things out. So we're going to step away from that for a second and do something that should actually be a lot more fun and interesting, since we're pretty darn close over there, and we're going to be able to polish that up with ease in the future. And what we're going to do is we're going to have the ability to have buildings mapped out on our planet, which is one of the other things that Mr. the MightySpud had requested out of this whole series over here, which is turning to be a much bigger series than I'd initially intended. So I'm sorry for the fact that it is taking a long time for us to work through. Anyway, we've got our topographical map over here of our planet. And what we're going to do is we're going to do something similar to what we did in a certain 2D platformer tutorial, where we went through how to make a level of a 2D platformer map over here in Photoshop by having pixels represent different things. We're going to do the same thing with our building map. Now, the very first thing we're going to do is we're going to make a copy of this. I'm going to save, instead of test topo over here, we're going to have one called, I guess, building_map. That sounds good. It's going to be based on the same thing over here. Now, this image that I've been working on is actually grayscale, so I'm just going to go and convert it to an RGB image. You know what? No, don't flatten it. It's fine. We're going to do that. We're going to start a new layer over here, which is going to be our actual buildings layer. And what I'm going to do is I'm still going to work in this general area because that's where we're currently rendering right now. And I noticed there's a crater over here that's kind of interesting because it's got an elevated area in the middle. And wouldn't that be a cool place to build sort of our evil layer or whatever it is? So I have gone ahead and I've taken the color red with pure red, 255 red, 00 for the green and blue over here. And I'm using the pencil tool with a single pixel pencil tool here. And all I'm doing is painting a single red pixel right over there. That's it. Then I'm actually going to go ahead and just disable all the other layers and save this. Now, if you don't have Photoshop, do whatever technique works for whatever you're working on. But the idea here is that the actual image is just going to be a fully transparent image, except for the pixels where we have buildings. It doesn't actually have to be transparent. It could be pure black. That's also fine. Something like that. It's going to be okay. But, your whole image is basically going to have a single flat color. And then we're going to use illuminated pixels to illustrate where the buildings will be. And then depending on exactly what the pixel color is, we can use that as a code for like whatever. It doesn't actually even have to be a single building. It could represent a whole base, for example. Which actually I think is going to be right. So we're going to have our little base is going to be over here on this crater. So I've turned off everything else. I've saved it like this. And then we're going to go into Unity. And there we go. We've got our building map over here. Now, we don't actually want to do, default texture is fine. I think the only thing we have to do, we could tell it that the alpha is transparent if we wanted the transparency to trigger, which I guess would be fine. We'll set alpha as transparent, so we should have a properly transparent image, except somewhere in here is a red pixel, which is hard to see, but that doesn't matter. In the end, there'll be like probably multiple red pixels, maybe some blue ones, maybe this, depending on what we want things to do. You can also do this with biomaps, by the way. We're probably not going to deal with that in our particular tutorial, but there is no reason. Where the hell did I even leave Photoshop? Oh, right over here. There's no reason that you couldn't do another one of these as a biomap, and you have a layer that's your biomap. In fact, you could have the same image. Well, you'd have to save them separately. So again, you put this back, and then you make a layer for biomap, and you paint like green areas somewhere, blue areas for lakes or something like that, and then just save that separately. Okay, so we've got that. We have to turn on the... Oh, we do have to go advanced for this. Oh, no, right here. Read-write enabled. We have to turn on read-write enabled so that we can actually access the pixels in code. The other thing we're going to want to do is turn off the filtering and probably turn off the compression, in fact. This may not matter. But for safety, we're going to go ahead and do that. And you can use the max size of whatever. Okay, so it's going to use the exact pixels that the image is made of with no compression and no filter mode. And the reason this is important is because we need to make sure that when we're reading the image information, we're getting exactly the pixels that we laid off. We need to make sure that as a result of compression, you don't end up with something, where's my water droplet? You don't end up with something that's slightly blurred in some sort of weird way, semi-transparent, or, you have a, a slightly less red pixel over here because of whatever. It's got to be precise, okay? So that's why we turned off the compression and we turned off the filter mode. So we should have that. I don't think there's, well, we don't need mip maps for this. That I don't think will hurt us, but we don't actually need them, so we may as well turn that off there. Okay, so we have the dynamic terrain master, which is fine. I guess we've always had a spot for this, for our structure map. Oh, structure map is what I call that. But that's okay. So we have building map over here. So I'm going to take the building map and throw it in the structure map texture pile there. And I think, and let's open up our code here. So the structure map, we do actually pass it to our dynamic, to our dynamic terrain chunk. We actually pass the structure map over there as well. So our dynamic terrain chunk has this structure map in place, okay? And so what it can do is it can build the entire terrain, and then at the end of it, so build terrain gets called. So dynamic terrain calls build terrain. Yes, okay, good. So our master calls the build terrain on our chunk. Build terrain generates the actual landscape. But then, now make the building, well, the structures. Yeah, I shouldn't call them buildings because it's all about building structures of some kind. It could be a giant boulder, a sculpture, a Mount Rushmore. It could be a whole base. It could be lots of things. So we're going to say, now make the structures. And I guess what I'm going to have is another function for that. So we're going to see, build structures. Seems reasonable, something like that. So we're going to take you, and we're going to go all the way down to the bottom, and we'll make a build structures function down here. So the idea with this is we're going to loop through each pixel of the structures map. If we find pixels with, well, really, if you find any pixels, find pixels that aren't transparent, or, whatever our criteria is, then we will spawn a structure based on the color code. So the color of the pixels we place are going to be code for which structure we want to place there. And really what we're going to have is, do I want to do it in place here? Sure. We're going to have a public class called structure colors or something like that. That's going to be fine. I'll take the American spelling for that because that's what Unity does. So this is going to have a public color and a public game object structure prefab, and we are going to have a public array of structure colors like that. So oh yeah, because you declared this in the same scope, so it's going to be whiny about it. I'm just going to do this. There's better ways of solving it, but it's going to be fine. Actually, you know what we're going to do? Do I want to move this out? Let's do that. If I can still define the class in this file, but if I do this, it's not going to be defining the class, which means it's not going to complain about having the same name twice. And this is convention for how you name these things. So what we can do, if we, again, I guess copy this from the master. Oh yeah, it will be. It'll be the same thing where we have, yeah, let me back up a little bit here. This structure colors, I'm going to cut it out of the chunk and define it in the master in the same way that we do with the splat data. So we're going to do that. And then over here where we have our structure colors, first of all, I'm going to move it up with the rest of the definitions. So say right after the splats over here. And we're going to have it in the master as well. So in the master, again, it's going to have the splats here. And what we're going to do when we create our chunks, we're going to make sure to say dtc.structureColors is equal to the structure colors from the master. So then in our master object over here, as soon as it compiles, there we go, structure colors, we're going to define one. We're going to say that the color where the red is 255 and the green and blue are both 0 over here. And the alpha is maxed out. Although we could just ignore it. That's going to be fine. That's going to be an indicator to build a certain structure. So let's go ahead, actually, right now, we'll go and create our structure. We're going to call this, like, cool base. We're going to have some sort of base that is really cool. So we're got that. I just centered it. It's going to have... maybe what we'll do is we'll pave the territory. I'm going to use a cube for this, which is going to be fine. We're going to say, so these are in Unity units, so meters. So let's say it's an area that's 100 meters by 100 meters, and then the cube, we're just going to leave it, oh, not that way. That way. So we're going to use leave the cube to be 1 meter thick. That's just going to be the pavement slab that we're on. So yeah, pavement, come on, pavement. And then we're going to, I'm going to add a cube, which is going to be building 1, which is going to be, I don't know, 10 by 10 by 10. Oh, it scales based, oh, yeah, no, okay, we have to put it separately because the scale gets inherited, and that's really weird. So we're going to do that. I guess it would probably be best, we'll raise up the pavement this way. So I'm raising up the pavement by 0.5 meter. That way the bottom of the base, the pavement is at exactly the 0 marker. So this building is going to go up by 5 or 6 meters to leave room for the pavement. Maybe we could do it the other way around. I know, it's fine. I mean, we're really ideally won't be like manual placing this. Let's make it, let's make this building a little bit longer that way. That's going to be fine. So it's 10 meters high, 20 meters long, and 10 meters wide. That's going to be okay. Let's add in, do we have cylinders? Cylinders is a thing, right? Excellent. We're going to throw in a cylinder in here. We're going to tell you that you are 20 high, so you're going to be positioned at 21 over here. And your radius is going to be 5. Oh, I'm doing the collider. Reset. Reset everything. There we go. So because I want to scale it here. There we go. 20. I think that actually makes it 40 tall because of the way that it's working here. There we go. And then 5 by 5 this way. Cool. So we have some sort of tower. It's like we're making an airport. That's what we're doing. We're gonna make an airport. So we'll park the we'll put the tower right over here. And then let's make something that looks a little bit more like a landing strip. So we're gonna do another cube landing strip like this. I am going to raise this up to 1.5 and tell it that it's I guess 100 long that way and then 10 wide that way. There we go. There. It's like a little Lego airport is what we're working on here. I will go, so I'm going to create a folder for structures. So cool base is going to go in there. But inside of structures, I'm going to create a new folder called materials. This is so much more fun than some of the other stuff we've been doing. So we're going to create a material. This is going to be called asphalt. Then we're going to have another one called brick. I mean, these aren't going to be textured. They're just going to be colorified. So the bricks are going to be kind of brownish. Excellent. The asphalt will be pure black, which it is. And we'll make another one for material, not C# script. This is going to be concrete, which is going to be gray. All right, and then in our thing, so we're going to have our asphalt goes there, brick goes on the building and the cylinder, and then the concrete. Right, I should actually call this is going to be, well, pavement, concrete, whatever. The landing strip is going to be the asphalt. I've just realized I've been fucking with the albedo, haven't I? Or the emissions. Whoops. My bad. All these should be set to black. That's why I'm like, these colors don't seem quite right. So it's the albedo we want to change. There we go. Asphalt goes black. Concrete is going to be gray. Sorry for the slight confusion there. Oh, it's gorgeous. It's beautiful. Should we put some little trees in here? Yeah, let's do that. So we're gonna have a material. I'm just gonna call it green. Is what we're gonna do. I guess we could make well, I mean, we're supposed to be on the moon, right? So what the heck would be green? Nothing. No, go away. Oh, that's what we'll do. We'll make some lights. Yes. Let me create an empty. This could still be a cube. That's going to be fine. We're gonna put them over here. So we're gonna make sure to elevate it to 1.5. I'll make them a little bigger. Actually, let's do a 2 by 2 by 2. So we actually want I don't know, 1.5 is correct here. Did I mess another one up at some point? No, we're okay. Well, that's the old directional light. So I want this to be a light bulb. Like that. We can actually put a light inside it, actually. That's probably a good idea. We're going to put a point light inside of this. I'm just going to move it to be slightly above our actual object, our cube, which... Can we actually see it? I mean, we can't see it because of the stupid light icon. Oh, I made this an empty. Let me try this again. Create 3D object cube, because I want to be able to see it. I want it to be a 2 by 2 by 2. You're going to be 1.5 units above the surface. You're going to be over here. Then inside of you, we're going to create a directional light. No, a point light. Excellent. We're going to take the light and just move you just above the... Yeah. No, that's going to be fine. And then... light bulb. And then I'm going to create a material for you, because this is going to look cool. So material, light bulb. So what we're going to do is we actually want you to have like no albedo. So let me apply the material over here, but you will emit some amount of light like that, and we'll make the actual light itself be like this. Excellent. Now, if we're using the fact that we gave this material emission would actually mean that it could emit light with the like global global lighting kind of engine kind of stuff, but in this case it just means it's going to glow in the dark, which is going to be cool, and then we're going to have the directional light provide the lighting in the... Well, there's a few different ways of doing that, but what I want to do is take this guy, duplicate it, put it about the same distance on that side. That looks pretty close. And then we're going to duplicate you there. Actually, what I should do is start on that side and then split the difference. There we go. That's what we're going to do. And like that. And then I can take these guys and move them kind of in the middle there. Okay. So sort of like a low poly little landing airport scene. I gotta call this good enough. It's fine. Okay, so cool base. We're gonna drop you inside of structures. So now we have a prefab for you. So we're gonna toss you, and we're gonna say now, whenever we've got a red pixel, we're gonna be generating this prefab, cool base, on the map. So now we can go back to our code and our dynamic terrain chunk and our build structures over here. So we're gonna say it's gonna be faster if we get all the pixels first. So we're gonna get the color array of pixels from our structure map texture dot get pixels, like this. Okay, so we're gonna get the whole array because it's much faster. So we're gonna say for x is less than structure map texture dot width, like so. Whoa! Oh, I hit page up. That's what happened. Boom. Height. This is going to be our y loop. Y, like that. Good. So width and height. So we're looping through everything in here. And then we're going to say if pixels probably faster. I guess it doesn't actually make a difference. Now, if pixels dot x plus y times structure width. Okay, this is this pixel. Actually, what I'm going to do to simplify things is I'm going to color, I'm going to call it p is equal to this. So this is our current pixel. If p dot alpha is less than 0.1, transparent, pixel, ignore. So we're just going to take continue, which will continue to the next iteration of this loop. But otherwise, we're going to say for each color, for each structure colors sc in structure colors, for each structure color sc in structure colors, which is our array. So we're going to loop through each one of those, and we're going to get a complaint and an error about it. Did I not call this? Oh, it is plural, which this should be singular, which means that that needs to be singular there, and that needs to be singular there. There we go, better. All right, so for each structure color sc in structure colors, if sc.color is equal to our pixel, can we just compare the RGB part of it? What I'm going to do, because if the alphas don't match for some reason, weirdness might happen, but let's ignore that until it might become a problem. If the color of our structure color is equal to our pixel, then what we're going to do is we are going to spawn the correct building, and then stop looping through structure colors. I mean, in a sense, we don't have to, because it won't match any others. So it's not like it's going to do the wrong thing. But if we had 100 different structures in that array, then it could take longer. So we'll just break out of. We're breaking out of the for each. We're breaking out of the for each and going back to the for loop. So we have matched it. So what we want to do is we want to instantiate a new object. So we want to the structure is equal to game object instantiate the structure color dot structure prefab. So we'll just instantiate it first. That's going to be fine. Well, we're going to need a position. Vector 3, pause. We need a quaternion, which is the rot. And I guess we can pass it there. Pause, rot. And then the parent is going to be this. We're going to make sure to spawn the structure as part of our current terrain chunk. That way, if we destroy the terrain chunk, or for some reason move the terrain chunk after creation, the structures will move along with it, which is going to be good, or be destroyed along with it, which is great. So the question becomes destroying this. Now, we are looping through every single pixel in the image right now. And that's not accurate. Well, because the question is, we actually only want to loop through the pixels that cover our terrain chunk, right? Right. But we don't actually have a simple map for that, right? Because think about it. Our terrain chunk at any given point, where's Photoshop? Especially if I bring up the background. A given terrain chunk might represent like this area. Although, again, as we know from, like, especially at the poles, the terrain chunks aren't going to be rectangular. But still, it's some number of pixels. And we can't just get the list of pixels. We can't just say, it's these pixels, you know, from 215 to 217, and so on and so forth. In which case, what we would do is we would only loop those pixels. But there's no way, I can't, like, when I'm looping through the positions, while I can convert and say, I've got, where is it? Right over here. I can convert from each one of these terrain points effectively into a pixel. We could totally do that because I could get a pixel cover at a particular point. But what's tricky about that is it is entirely feasible it's conceivable, depending on the resolution of our terrain, that we might never actually directly read the 1 pixel that we painted red for the base. Or, and this is far more likely, at multiple points in here will we be reading from the same pixel, and we could accidentally spawn multiple copies of the base. So I think the answer is we do loop through each pixel of the texture. And then we can ask, is this pixel within our map? That's interesting. There's actually a few different ways of approaching this. So the missing steps are this. Before we spawn the correct building, we want to say, what is the position of the building? And actually, not this position, but rather something like our latitude, longitude. Or, in fact, in this case, we're going to care about the quaternion, right? The quaternion lat longe of the building is what? And then, is that within the range of this chunk? Now, remember that mapping this is kind of annoying, right? Because of the shape of the square not being a square in the first place, and it gets a little bit more complicated when you consider the fact that your chunk can overspan an edge here, and in fact, it can do it in sort of an inverted direction than you think. So just testing sort of your normal X, Y, kind of like limits gets a little bit trickier, but it should be pretty easy over here if we've got the quaternion, because the question is, are we within, what's it called? Chunk degrees, degrees per chunk. What do we call this? Degrees per chunk. Are we within degrees per chunk divided by 2 of the center of the chunk along both directions? Right? If we're within 5 degrees, on the sort of X-ish axis, and also within 5 degrees of the Y-ish axis, then we know that we're within the chunk and we can continue. Otherwise, this building isn't actually within range of the chunk. There's probably a way to optimize our looping through the texture for this, but again, because we could be going in an unexpected direction along the UV axis, and it could cycle around, things get really bizarre. I thought, like, one of the things we could do is, while we're going through over here, we could sort of convert our UV into an integer-based pixel and flag all the pixels that we're actually reading from. The problem is there's those 2 parts. In theory, the first part is the structure map doesn't have to be the same resolution as the terrain map, although in practice it probably will be, just because it'll make our life simpler, but it really doesn't have to be. So the actual pixel integers don't need to match up. And the second thing is, again, depending on exactly how big of our sections are and what our various resolutions are, it's possible that we don't actually bop, and the resolution of our terrain chunks, it's possible that we won't actually bop every single pixel within that range. We could skip one, and that could happen to be the one that has the building in it, and then we never actually flag that that's one of the ones included in our chunk. So I think this is going to be the most bulletproof one, assuming we do it right, but it may not be literally the most optimized one. We can look into ways of optimizing it down the road. But the first step is this. We need to know with a quaternion, right, the rotation that represents the position of this building based on the pixels. And to me, that means we go into coordinate helper. Now, we don't currently have anything that goes from, say, a UV to a rotation. But it's not too hard to do that, because that's really what I'm looking for here. I want a function, public static quaternion, that is a UV to rotation. And so it's going to take in a vector 2, which is the UV. Because that's how we're representing it, right? Yes, that is indeed the case. So that's fine, because what we're really doing then is we're doing a new, we're returning a new quaternion using the Euler helper. And let's ignore the x-axis for a second, okay? We can start with the y component, right? The y component is the bit that goes through the planet, and therefore a rotation around the y-axis is the same as moving from left to right in our topographical map over here. So that would be the x component of our UV. So what we're going to do is we're going to rotate 360 degrees times the UV X component. Well, it's sort of the U component of the UV, but we're mixing our terms because that's fine. Okay, so we're rotating through the y-axis, spinning the Earth around based on the x. We may have to throw in a negative sign here depending on how things go. We'll see how it goes. And then rotating around the x-axis in exactly the same way based on the v component, although in this case, it's a little trickier because remember that we have gone and accepted that a 0 rotation around the x-axis, or in other words, a 0 degrees around the of latitude, is the equator, okay? The equator over here, which means that our when the UV component says 0.5, so because our UVs go from 0 down to 1, or maybe the other way around. We'll double check, right? Our UVs go that way. So we need, when it's at the 0.5, that's when we have to return 0 degrees of rotation. And at the top and bottom end, we have to return plus or minus 90 degrees of rotation in there. So what we have to do is something like, let's assume, so it's a UV dot Y. And again, notice that, the X and Y aren't, the Y's are going to the X part and the X's are going to the Y part, but that is correct. So if we take this and we go negative 0.5, so now this value is going to range from negative 0.5 to positive 0.5 instead of from 0 to 1. And it's going to be that multiplied by, I guess, 180. That will ensure that this number results in a rotation from negative 90 to positive 90, which is correct. Why are you being highlighted here? Sure you do. Quaternion. Burr. Oh, no new. Get rid of the new. Dot Euler. There we go. That's going to be fine. So again, we might have to invert the sign of this part, but maybe we don't. So we've got this UV to rotation. So what we're going to do is say chord helper dot UV to rotation, and in this case, our UV is going to have to be in U vector 2. Where we are taking x divided by the width and y divided by the height, because UVs always range from 0 to 1. They could exceed it for a loop around, but we're going to do that. So there we go. We're converting our x and y pixels to some sort of UV value over here. Now, I believe these are all integers at this point, the width and x itself, so we will have to force a conversion over to float so we get a proper decimal number. Otherwise, this would always equal 0 or 1. But now we should have that, and then the question becomes, are we no more than 5 degrees of rotation in both components? We can't just compare the angle between the two. If that's even a thing that is possible. Oh, there is, yeah. Oh, angle axis, I think, is what we actually want. Nope, it would be nice. But this will, if we just use quaternion.angle and compare two quaternions, then it will return the absolute angle between them. And the problem is that this will be sort of a circular thing, which means if we give it a rate, if we're comparing against a radius of 5 degrees, it's going to cut out a lot of the corners and not be right, or we could overshoot it. So we don't have to do that. We can't do that. Are these deprecated? Could use that. Yeah. The problem is if I do this, because we just want to compare the two. So let's say, so my Paulat-Lang dot, and I think it's just Euler angles is what we're looking for here. I don't think there's anything else that'll help us. Yeah. Or would it? Could we do a quaternion dot from to rotation? And would this be sufficient? I'm actually not sure that it would be. No. All right, let's just do this. Paulat-Lang dot Euler dot x. So make sure we're not... Oh. Check the x rotation. So if our current latitude longitude of this building that we found, dot x, minus the chunk rotation, dot Euler angles, dot x. I guess we're going to want to do a float x diff is equal to this. The problem is if there's like a weird wraparound, right? Like, let's say it's possible that, well, I guess these are always going to be from 0 to 360. But they might be like the wrong way around. Like this could say 359, and this could say 1 degrees. And so subtracting one from the other would result in an answer of 358. So I guess if it's bigger than 180, if the x diff is bigger than 180, then what do we do? We subtract 360 and use the absolute value. Because what are the cases? The cases are, like, because we want to make sure that x diff is less than degrees per chunk divided by 2. Right? Which in this case, if we're using degree, well, right now our chunks are actually 5 degrees. So degrees per chunk divided by 2 is 2.5. But there's lots of cases where this equation will not give us what we want. There's sometimes it will. It'll be 3 minus 1 is equal to 2, so that's good. But in the example of 359 minus 1 would be equal to 358, even though that's inaccurate because they're really just 2 degrees apart. So I think if it's larger than 180 degrees, then we subtract 360 and do the absolute. Because that's going to be the most extreme situation. Because there's never any case, there's no math that would legitimately put them... No, that's not true. Because what happens if our values are 182 degrees and 1 degree? That would equal to 181. Oh, no, that's okay. Because then we say, oh, it's bigger than 180, so subtract 360, which would end up at minus 179. If we took the absolute of that, it'd still be outside of range. I think that's okay. This is the sort of thing I F up, though. X diff. If X diff is larger than 180, then X diff is equal to the absolute value of X diff minus 360. There we go, something like that. If the difference is larger than this amount of degrees per chunk, not in our chunk. So we just we're going to continue to, and we'll scan the next building instead of continuing here. So we're going to do the exact same thing in the Y direction. So I'm just going to group these things up a little bit. I think this is okay. I don't like that I'm doing so much work here that I can't test because, and of course all these little math things with signs and stuff, because there's a very large chance that I'll make an error. And the problem is, if I do, it's going to be hard to track down exactly where it is. I guarantee there's going to be at least one error in this process. And it's going to be hard to track down, which is kind of sucky. All right, but we're at this point now, so I guess that's a ting. You know what? I'm not going to do the absolute here, because there's a chance that our first subtraction returns a negative number. So yeah, we have to make sure to move the absolute function here. mathf.absolute. Like so. There we go. If the absolute value of this is bigger than, well, in this case, 2.5 degrees, then it's not in our chunk, and we just continue. So we got that, we got that. All right, spawn the correct building. So we still have the problem where we actually don't know where the position and the rotation of this is, but let's go ahead and try to run this thus far. So we went and put right over here, which if we bring up our letters, just to the right of the E, there should be a building that gets spawned there. Well, probably first of all, there'll be syntax errors. There we go. Excellent. Okay, we're using something that hasn't been set. So I'm just going to set vector 3. Here, vector 3 dot 0 and quaternion.identity. There we go. So the building's not going to spawn in the right place. But that's okay. The variable structure is assigned but not used. That's okay. We do instantiate things. So we're going to hit play, and are we going to get an infinite loop? No. It did take a lot longer to process, but I guess that's to be expected. And so, okay, none of my chunks built the building, and it should be right here. There's our spot there that should have built the building right on top of that. So there's definitely an error in this code. First of all, does build structures actually get called? That's an important question. I should put some comments in there. It does. It do. That's fine. So most likely it's this. If I go and comment that out, let's make sure it actually finds the building. So this should result in every single one of our chunks spawning one instance of the building. And slightly longer to do because we're looping through this entire building thing multiple times, which again could be something for optimization. Okay, none of the chunks are actually spawning the building. Structure colors are in here. It's got our color, but it's not actually doing it. That's very interesting. Oh, I didn't comment this one out. Hold on. Try one more run. Again, we're hoping that every chunk generates one of these buildings. And it doesn't. Okay. So I'm thinking it doesn't do a color match. I guess I can throw in a debug.log color match like that. Not transparent. So every single one of our chunks should find one non-transparent pixel, and it also should match the color in the array. So let's run that. I don't want to set a debug command yet just because that's such a huge loop. And again, each one of these things is looping way too many times. We'll have to find ways to optimize things. But again, this is actually going to be a good set of things for us to multi-thread. And really soon, actually, what I'm probably going to do very soon between episodes. I know we did a stream for multi-threading, but specifically I'm going to develop a proper implementation of our thread sort of pooling system that will be very helpful for this. This is taking extra long. I feel like it's probably going to spam the console a whole bunch. Or is it because the continue is not popping here? Are we actually hitting too many things? Why is this taking longer? Is there any chance that it's spamming the hell out of not transparent in a way that I hadn't expected? Yes, it is. Why is that? So what we're hitting here is a pixel that is very gray. Its blue, green, and red component is all at 0.33. It's a gray pixel with an alpha equal to 1. And if we hit play, we will hit Is it using the right structure? Are we reading the wrong image? This is all grayscale stuff. Every single one of these pixels is some shade of gray and full alpha. That would not be helpful. Let's turn off the debugger. Is there a good way to just kill the app at this point? I actually don't know. How do I just stop the app from continuing? I mean, I can make changes to the code and force a recompile. And then that might cause an issue. Int a equals 1. Save. Play. I think I might have to Control-Delete out of Unity to stop it from running like mad. Yeah, let's go ahead and do that. But I think it's reading the wrong image. So somewhere along the way, I assigned the wrong thing. Okay, let's restart Unity. Bam. Can leave MonoDevelop open, that's fine. Load faster. I don't know why Unity takes so long to load in the first place. I don't know, I guess it's got a lot of stuff in its library. I guess that's reasonable-ish. I'm just very impatient. Oh my god, this really takes a long time. Come on. Okay, Dynamic Terrain Master. Your structure is the building map. Oh! Last time I tweaked this, I made the background visible. Save. That's the problem. Okay, so we're back to a mostly transparent image now. Oh yeah, that's one thing. So let's get rid of this. Boom. Save view again. Come back over here. Hit play. But yeah, that's why. Every single pixel it found was not transparent. So it was spamming out not transparent here. Okay, so now it should not spam out not transparent very much, and it should run. I mean, it still takes longer than we're going to like, but it's not going to be like stuck forever. The problem is if you spam the hell out of the debug log, things take forever to run. Okay, so we got a bunch of messages about things being not transparent. Actually, more than I think there should be. Let's include some extra information here. Not transparent plus p dot toString, because I want that information as to what that pixel actually is. Because this should only show up 9 times in the log. It's finding the last value is the alpha. I actually don't understand this. The last value is the alpha. It should be 1. I mean, this is it's definitely finding a red pixel here. But it's finding semi-transparent red pixels, and more than I expected. But why? Building map is correctly set to not be filtered or anything weird like that. And it shouldn't have any sort of weird alphaness going on a channel. It doesn't even have an alpha channel. It's fully transparent, 100%. And that, I mean, you can't assign alpha values in Photoshop over here. First of all, like, I think that's more than 9. Where's my Unity here? The order of things is different. Well, it's definitely more than 9, which has me very confused, and I don't know why it's getting things with an alpha value that's not literally 0. Okay, well, let's make a slight change over here. When we found a non-transparent pixel, just for testing, we're going to force the alpha to be exactly equal to 1. Oops. P.A is equal to 1. And the reason I'm doing that is because when we're looking through and comparing colors, it has to compare against something that is 100% alpha, because otherwise it won't actually compare. So now we're going to force that to be equal to 1, which means now, there we go, now we're finding buildings. But we're finding the building multiple times. See? See what I'm saying? How's that possible? We're looping through the structure map texture and finding multiple semi-transparent red pixels. We have everything turned off. Max size is irrelevant. No filtering. Repeat mode doesn't matter. Oh, shit. It's because it's a non-power of 2 and it's doing some conversions. That's the problem. Hang on, we gotta apply these changes here. Yes, when a Unity, when you're using a regular texture, it's not power of 2. Unity actually optimizes things by forcing things to be a power of 2 because it actually is more optimal for your video card to work with power of 2 stuff. But in this case, we don't want it to do that because that's what was fudging up our pixels. I thought I turned off everything that would fudge our pixels, and apparently I did not. There we go. There we go. Now you see we should get exactly 9. There should be 1 in each one of these. and there's 9 chunks there. See, there's 1 in each, and you can see it's actually responding a alpha value of 1. And keep in mind, this is not because of this. If I remove this, because we were debugging that first, so it is now correctly finding. Okay, God, I was getting really, really, really stumped and confused there. There we go. So we can check out and confirm that cool base is there, and it's spawning in the same place. All 9 of them are spawning in exactly the same place for now, but we are correctly detecting that red pixel. My God, I thought I was going crazy. Now, one thing I'm realizing, what we actually want to do is we don't want to work with color, okay? In our array over here, we're using color. We don't want to do that. We actually want to use color 32. And the reason for that is, I mean, I guess this can still be called color, but the type of that thing has got to be a color 32. And over here, when we get the pixels, we don't want to get pixels. We want to get pixels 32, and it's going to be stored in an array of pixel 32s. So the reason for this is such. The difference between a color object, okay, is a color object is made up of floats. 1.0, see, this would be red, right? 0, 0, and we can give it an alpha value of, say, 1. A color 32 is made up of bytes with a value from 0 to 255. So these two colors are exactly the same. C and C32 in this case, these represent exactly the same color, pure red. The difference is this. The difference is representing things as a float versus representing things as a byte, which is an integer that ranges from 0 to 255. 2 things for this. First thing, internally, your video card actually uses the bytes over here. So when you ask for a color object, which is a float, Unity actually has to convert from bytes to a float, and then if ever you reassign those pixels back again, it has to convert from the floats back to a byte. So there's some overhead in working with the color class as opposed to the color 32 class. Although oftentimes you do actually want to work with the float, so you may as well get Unity to do the work for you because they may have some internal optimization to do that. The 32s, in addition to being faster, also lead to, when we're comparing exact colors, more precision. Because we want to make sure that we're not trying to, when we're talking about an exact shade of red, like red 255 is this base. Red 254 will be another type of base. And if we're working with floating points, there can be some floating point inaccuracy that means that it won't actually notice that one is the exact color that we're asking for. So we want to work with the integer components so we have the exact capacity to map. So that's going to be good. We're going to score that color 32. If the alpha is less than, say, 128, then we're going to ignore things. That's going to be fine. And then we get to match things directly all of a sudden. Okay, that's much, much better. We do have to go, most likely in Unity, the dynamic terrain master at this point. And really? Apparently, you cannot compare a color 32 to a color 32. And despite the fact this is sc.color, I mean, color is the variable name, but it's of type 32. So, and if you look at the error message, we are correctly trying to use the equality operator between a color 32 and a color 32, but apparently that's not in there. We could overload it, but I guess the other way to do it is to just compare the red and the color.green is equal to the p.green, and the sc.color.blue is equal to the p.blue, like that. And we don't actually have to compare the alpha because we don't care about it. All we care about is that it's not a really transparent pixel, and then we can go right ahead to comparing the color, which is what we're doing over here. So that's good. So we've got back there. Compile, compile, compile. Okay. There we go. Terrain master. I was going to say that color probably got reset. So again, we want to go here. And note, we are working to 255,000 as opposed to, I think before, we can compare this to when we're, say, working in a material over here and setting a color. It always has. So again, it's always working the color 32s internally, which is interesting. Okay, so again, if we hit play, we will once again be spawning one building for each terrain chunk because our code to verify that a building is within our range isn't running right now. So we are getting that in there. So that, okay, we know that works. So let's re-enable these continues here, which confirm whether or not something is in our current chunk. Now, if something's not in our current chunk, we will bail. And I guess what we can do is we can group this slightly better, I think. If we do this, so we'll calculate the X and Y positions here, or the differences, and then in one comparison, we'll say, if it's outside of our X range or outside of our Y range, then we continue because it's not in our chunk. So now, only one of these chunks should spawn the building. Still takes a while to run. Aha! Only one chunk spawned the cool base over here. Now, the cool base is still being positioned just at 0, 0, so it's not showing up in the right place. But let's see, what chunk is this that created the cool base? It's the chunk at the bottom here. This chunk over here is the chunk that created the cool base, and you can see that the cool base definitely belongs to this. And that's right. Now, the only thing left to do is to position the cool base in the right spot over here, right? Right over there. Which, what we're going to do is, this video is probably gone on way too long. I think we're going to put a cut in here. We got a bunch more little work to do for this. It's not just position, it's also going to be rotation. So we'll save that until next time. Thank you very much for watching, folks. I'll see you then. Thank you, all our March Patreon supporters and these mic check supporters. We've got Yukofin, Snoopy TRB, Pavel Zdanov, Drazion, Gavin Power, Jan Torrevel, Michael McClintock, Aaron Doibson, Craig Mortel, The Not So Evil Engineer, Julian Ogenafon, Marisfield Vold, Speedy Savant, Steven Stager, Valiant, that's probably Stager, I don't know, Valiant Cake Fiend, Jason Yanity, Stephen Bonnerman, Kale the Quick, Neil Blakely, Milner, and everyone who has watched, shared, favorited, and subscribed. Thank you so, so much.